Mixtures of gases require the use of an equation called Dalton's law of partial pressures. Dalton's law of partial pressures is where the total pressure is equal to the sum of the individual pressures or partial pressures of the gases in the sample. And you can be adding 2, 5, 10 gases together to get that total pressure. It doesn't matter. Here, the A, B, and C are just referring to the different gases that are part of the sample. You just need to make sure that your units match. So if we're doing student exercise 8A, which says a mixture of helium, neon, and argon has a total pressure of 558 millimeters of mercury. So you're going to take 558 millimeters of mercury and set it equal to the partial pressure for helium plus the partial pressure of neon plus the partial pressure of argon. So your equation would look like this. They gave us the partial pressure of helium as 341 millimeters of mercury, and the partial pressure of neon is 112 millimeters of mercury, and we're looking for the partial pressure of argon. I just took out the millimeters of mercury to simplify the equation, okay? In order to solve for the partial pressure of argon, subtract 341 and 112 from 558. And you're going to get 105. So the partial pressure of argon is 105 millimeters of mercury, okay? Which looks like this. There's another equation on your worksheet for Dalton's law of partial pressures, and I gave it to you in questions 3 and 4. It's not in the textbook, but it often shows up in introductory chemistry classes, which is why you're going to see it here. So take a look at the worksheet for Dalton's law of partial pressures, which looks like this, and I want you to take a look at numbers 3 and 4, which have an equation in parentheses after the problem. So if we're looking at number 3, I gave you the equation of P total times some percent is equal to the partial pressure of some gas, and I'm just going to call that gas A. P total is the total pressure. You multiply it by the percentage as a decimal. So if you're given 98%, you would input it as 0.98. And that equals the partial pressure of whatever gas you're collecting. So in number 3, it says the pressure on the surface of the moon is about 80 atm. Carbon dioxide gas makes up about 98% of the atmospheric gases on the moon. What is the partial pressure of carbon dioxide in the moon's atmosphere? So your total pressure is 80 atm. Your percentage as a decimal is going to be 0.98, and you're solving for the partial pressure of carbon dioxide. So you would set it up to look something like this. You would simply multiply, and then you would have your answer. This is not a unit. A lot of students are making this mistake. This just means the partial pressure of whatever gas that you're looking at. This is a unit, okay? Your unit for this problem, or for your solution to this problem, would be in atmospheres, which is atm, okay? Okay, now, you're going to follow the same setup for question number 4, so I'll just let you do that on your own. The other part of mixtures of gases pertains to collecting gas over water. So you're going to want to turn in your handout to page 5, and we're going to look at an equation that it's kind of just a variation of Dalton's law of partial pressures. So anytime you read a problem that says collecting gas over water, you have to use a certain equation that looks like this. Okay? So it will always be this equation, and the total pressure will be equal to the partial pressure of the gas that's being collected over water plus the vapor pressure of water. So you're going to want to make a note that this pH2O means vapor pressure of water. When you're doing a problem that involves collecting a gas over water, they will often tell you the temperature that the reaction is taking place at, because the vapor pressure of water changes based upon the temperature. In the old days, they used to make us look up the vapor pressure of water at a given temperature in a table, in some sort of reference book at the library. Now we don't do that. I give you the vapor pressure of water in parentheses after the problem. So if you take a look at student exercise number 9, the hydrogen gas formed in a chemical reaction is collected over water. You should highlight or circle collected over water at 30 degrees Celsius at a total pressure of 732 millimeters of mercury. What is the partial pressure of hydrogen gas collected in this manner? Vapor pressure of water at 30 degrees is 31.8 millimeters of mercury. Okay, so the total pressure is 732. We're collecting hydrogen gas over water, and the vapor pressure of water is 31.8. So you simply input your numbers to the equation, subtract 31.8 from both sides, and 732 minus 31.8 is 700.2 millimeters of mercury, and that's it. You are done. Okay? All right, so you're going to do the worksheet on collecting gas over water using that equation, and it's really straightforward. You just have to make sure that your units match. I want 3 significant figures for collecting gas over water and for Dalton's law of partial pressures. On the collecting gas over water worksheet, I believe there are a couple problems where the units don't match. You just need to get them to match. It doesn't matter which one you pick as long as they match.